Okay, so hello everyone. Can you hear us? Can someone type? If you can hear us, please type. I just want to make sure that we're actually live. Okay, hello Antoine, can you hear us? Yeah. Okay, thanks, Jim. Okay, so welcome to everyone. Those of you who are returning and have been on previous Stark at Home episodes, and those of you who are new. So basically, starting pretty much with the whole COVID situation, we started giving a bunch of talks that sort of dive a little bit into this particular kind of zero knowledge math or science and technology called Stark, which is what we're passionate about. And I think this is like by now probably event number 15 or 16. Those of you who are curious about the math and applications of Starks are welcome to go and check out a whole bunch of other crowdcasts there that I just posted in the chat. My name is Eli Ben Sasson. I'm co-founder and president at Starkware. I'm joined here by Louis Gutmann, who's a blockchain researcher at Starkware, and also with Andre Cronje, who I'm sure does not need very much of an introduction to most of the crowd here. Andre, do you want to say a few words to the folks?
No, just thanks for having me. I'm looking forward to I think right now everyone's definitely talking and excited about the L2 space, and especially the sort of ZK rollup / Stark space. So I think this is a great chat to have, and I think the timing is absolutely perfect. So thanks for having me. I'm looking forward to it.
Okay. Thank you. So the plan for today, I just want to give a little bit of context and then pass it over to Louis, who's going to give a presentation and discuss it with Andre. First of all, just for those of you who are unfamiliar, there's an Ask a Question button. So I'm just now writing a question there. You can all post your own questions. The point is that while Louis will be presenting, we won't be able to see much of what's going on in the chat. So basically the way to ask questions is going to be through this interface, and we'll pause from time to time to answer questions. So basically what we're interested in is today understanding a little bit more about how you can apply ZKPs and in particular Starks to create some L2 systems. So it's a system that takes a lot of the information off-chain and works very well with things like DeFi applications, and that's going to be the nature of the talk. For those of you who are unfamiliar, let me just sort of just because some of the folks out there probably are just ZKP researchers or folks in general interested about it. So blockchains in general are these maintain some state, and this state has a lot of economic value to it. So if you have in your account, under your public key, there's 1 Ether, this has a pretty large purchasing power to the tune of roughly $1,800 today, and who knows what the price will be tomorrow. So you have this state that has a lot of economic meaning there, and because of this, so this is L1, layer 1. This is where truth resides and economic value resides. And now, because everyone wants a piece of this and wants to interact on it, and there's this sort of assuming that this is the truth, there's also there's instant finality for all economic transactions, because if I transferred my funds over to Louis, then immediately now he has this. If I gave him 1 Ether, so now he has this purchasing power, and immediately he gets it. So there's a beautiful ecosystem of decentralized financial applications, which Andre Cronje, pretty much jump-started and contributed much to. And now, because of all this huge success, there's a lot of demand for using this thing, and blockchains are very slow. So because of that, you would like to sort of take all of this action and put it off-chain. But and this is what we call an L2. So you want the state of the world and what happens to be not on L1, where it has all this economic value, but on something else. And now immediately there is a problem that's going to arise, because how do you sort of use the fact that the stuff now doesn't reside where the real truth is, and still have the ability to transact very quickly, and also have it be reflected correctly in the true state, which is in L1. And this is the nature of the problem that Louis will discuss. And the particular technology of zero-knowledge proofs is one way by which you can sort of assert very efficiently on L1 things that are correctly happening on L2. So without further ado, I'm going to hand it over to Louis. I'll just point out that if some of you are intrigued and want to implement some of this stuff, you want to say, oh, this is really great, this technology is really great, I want to build my own AMM or yield farming or anything on L2, but I don't know how to use ZKPs or whatnot, then there is a solution for it. We have made accessible a framework and a programming language that allows you to program stuff, and you can just go to these two links. You can start programming, and basically the systems that you build will be able to create L2s that have automatically proofs asserting their validity on L1. This is through the Cairo framework, and coming very soon to it will be a tutorial that explains how you can write an AMM, no less, in Cairo, and sort of get it to be this L2 AMM that interacts very nicely with L1. Of course, there'll be some, it's going to be a tutorial with some missing holes that you need to fill in, but all the more fun. Okay, so I'm going to hand it over to Louis, please.
Thank you very much. Thank you very much, Jenny.
Do you want me to?
Please let's go full screen, and then we'll take off the. Okay, if I need to do this, then I'm going to take. Okay. Great. Oh, that's not what I want. Okay, great. Thank you everyone for joining, and thank you for the second most important person of DeFi blockchain in 2020 to join us. Huge fan of Andre's work, and I think he definitely deserves the second place. So more without the topic of today's talk is going to be capital efficiency in the context of the in the L2 era, and I'm gonna what capital efficiency in the L2 era in the context of DeFi. So as one may not know, DeFi is basically finance on the blockchain, and more specifically on Ethereum. So the reason why we care so much of putting finance on the blockchain is because having the finance on the blockchain provide kind of amazing features. And the first thing is it's programmable. I mean, it means that I can just run a small program, put it on the blockchain, and then it runs automatically. And the second thing is just that now it's connected to everyone. And in addition, it's obviously permissionless, meaning that I don't have to ask permission to my bank to deploy this, to create this new cool financial tool. And because it's also permissionless, I don't have to log in, I don't have to have a password, I don't have to have to show my ID to create my KYC to send papers. And the last thing, and the reason why the thing we're going to talk the most about tonight is capital efficiency. And capital efficiency means that because on the blockchain, all the markets are united and unified, as a trader, I will always get the best price. Another thing is that as a trader, I can move my assets very efficiently across all opportunity that comes around. And for any financial person who work in the traditional finance, this is something traditional finance can do. And I'm going to give you a very specific example that happened no less than 2 weeks ago, where this lack of capital efficiency creating huge drama in the financial world. And this event was a GameStop frenzy on the stock market, on the American stock market. And when Robinhood had to prevent people from buying the stock, because they had this problem of finalizing operation. So in traditional finance, when you buy an asset, you technically only receive it 2 days after. It's called T+2. And because all of a sudden, and during those 2 days, there is various risk that the different parties needs to insure against. And because of the frenzy, the number of transactions that came to Robinhood was so big that their insurance guarantee they had to give to the company, the insurance company, 10x. It became 10 times more expensive. And they had, the only solution they find was to prevent the users to buy the share. And they had to get a last minute bailout by various partners to make sure that it could work on the next day. And when you look at the DeFi space, T is T+epsilon. Epsilon being the inclusion time, usually the block time. And so this is amazing. This is what DeFi is so cool. But it triggers obviously a lot of success in interest. And we hit one of the core issue of Ethereum, which is scalability. So I won't get too much into why we have scalability issue. If you want to learn more about it, I invite you to go read what the core dev writes, what Peter is writing, what Martin is writing from Geth, what Alexei from TurGeth is writing, all of those guys. But kind of one of the core reasons is because we have one single state. And this question of scalability has been around for a while. And one of the way we plan to, the ecosystem, the community is planning to solve it is through rollups. So rollups are a specific kind of L2. So I don't know if everyone is familiar with the notion of L2, but for anyone who's been around, there has been different proposals to enable blockchain to scale, from sidechain to plasma. But the latest iteration, and at this point, the most likely to succeed, is rollups. And rollups are called L2s, but used to be called 1.5. And the reason for it is because rollups security only depend on the security of the L1, of Ethereum. So that's very cool, and that's what Starkware is doing. They're writing a ZK rollup, but it brings a paradox, because kind of the success of the DeFi was very successful, and because it was very successful, it brought a lot of demand, and a lot of demand for the block space. And with that demand, now the cost of the transaction became very, very high. And kind of the reason why it became so successful is this capital efficiency, this single state that everyone shares. And the solution to the high price are the rollups. And what do the rollups do? The rollups are all about splitting the state. So I invite you to look at what James Prestwich wrote. James being one of the great minds when it comes to protocol layer of blockchains, and he says it right away. You cannot have cheap fees on a global consensus. If you want it, you need you can't have it. So there is a paradox. One side we have, like DeFi, which is successful because of the one state, and rollup, which are successful because we split the state. And these seem like, what can we do? What can we do about this? And the general wisdom at this point is kind of the following two options. The first one is just say, okay, we're going to split liquidity across the various L2, and we're going to bridge it, and et cetera, et cetera. And it's kind of suboptimal. Everyone knows this. Or the other approach is to say, everyone is going to move to the same rollup, and everything is going to be fine. So the problem with that second solution is that, first of all, going on a single rollup up to a scale, and the scale is a very complex question, and VK rollup versus optimistic rollup comes along, and it's too deep a question to address today. If you want to, I would please reach out to me. But it also meets a second important step, which is the network effect. The success of Ethereum today is the number of projects that we have around. And for this rollup, this big rollup to be successful, it needs to basically have everyone move right away. And it's very unlikely to happen. So today we want to present like a third path. something that will enable to benefit still from the network effect while enabling users to remain on L2. And so the notion I want to introduce is we should leave the liquidity on L1, but aggregate the demand on the L2s. So when at Starkware, we were working on how we can bring that up, how we can scale DeFi, how can we scale the operation. We had kind of two design goals. First of all, every L2s must have access to the liquidity. And we should enforce very minimal protocol change to existing projects. So I'm going to present there is a bunch of solutions and things you do on DeFi today, and we can summarize them to roughly 5. The 5 operations usually do on DeFi are lending your money, yield optimizer, using a yield optimizer like Wi-Fi, like what Andre basically started, which is trying to actually I see that there is a so yield optimizer, which is trying to optimize the rate you can get on your assets, and staking. Staking is a way to enable voting on a governance problem. The second thing you want to do is borrowing. What I want to do is I want to I believe a dollar is a shitcoin, and I want to short it by buying Bitcoin. So some people don't believe so. They were just going to lend me their USDT, and in counterpart, I'm going to pay them in interest. And this is what is very important. Borrowing is very important. And at last, there is exchanging, markets. And all of those are what defining DeFi today. And before I dive into the solution themselves, does anyone have questions so far? I think there is already one, and I will take it. And that was you. So is there any question then? So first of all, maybe I can ask Andre, did I miss anything from your perspective when it comes to DeFi?
No, that's solid. You've got AMMs, you've got lending protocols, and the underlying assets themselves, I might say, is a category in their own. But yeah, pretty much nailed it.
Okay, awesome. Thank you. I appreciate it. So then I'm going to dive a bit about what the solution we are looking at. So for those who are familiar with what Starkware has been pushing, like as research, as blog post, we have presented something called DeFi pooling. DeFi pooling is very cool because it enables you to, if a bunch of users, a trader wants to do the same thing, we're just gonna batch them into a single L1 operation, and those end users are going to share it. Like 1,000 users are going to share 1,000 of the transaction on layer 1. So today, for instance, depositing to Aave could cost $120. With a DeFi pooling, I could lend that for 12 cents if I had 1,000 people to share it with me. Yield optimizer is roughly, lending a yield optimizer is roughly the same thing. I could just deposit there and share it into a single batch. And staking is kind of the same logic, very simple. I deposit, I get something that says I deposited, and everything's fine. So DeFi. So this is what DeFi pooling enables you to do. It's a very simple, doesn't require any change from existing protocol. When it comes to borrowing is a bit more tricky because you need some individual level of account management. But nevertheless, borrowing is to some extent, and this is debatable, to some extent similar to lending in the sense that it's not a very time-sensitive operation. It could be, but it's not necessarily a very time-sensitive operation. And in that context, what I can do is the main difference with borrowing is that I need individual account level of access. So the way you can scale lending is by basically committing off-chain all the collateral user wants to do. Like let's say 100 user wants to borrow USDT, and they want to put different collateral. What they could do is commit the various collateral, move it from L2 through to L1, but have an efficient commitment on L1. And this is the last one is what I'm the most excited about, is how can you get across L1, L2's IMM, meaning something where we don't have to move the liquidity on each L2 and share it among all different L2s. So I'm going to dive into this specifically because this is what I'm the most about. Oh, there is a lot of questions coming in, so I'll be more happy than to. So
wait. So now what you do is, first of all, press
delete this one,
and then when you start answering.
Start answering. Okay.
Yeah, go ahead.
Can you Miss Script? Can you go further detail into the cross L1 L2 bridge will work? So I'm going to dive into into this a bit later. So please keep it. It's as we say when you present, it's a great question. So I hope it will be answered in the a bit later, because that's how we're gonna address. Like I'm going to show the different ways you can address it. I'm going to ask it because apparently Sushi also. So I'm going to do that. You can start answering. I will touch Andre Lift. Since you're working with Sushi, apparently I guess you are in the most ripped team. Are you working out, Andre?
Myself personally, yeah, I hit the gym at least 5 times a week.
Wow. Okay, so that's answer that question. So now, okay, answer the question. Answering. Okay, what are Starkware expectations for the permissionless and censorship resistant of DeFi pooling? For example, do you see a third party as able to add a new token and a new use case for existing token without asking or telling Starkware? That's a very good question. And the short answer,
I can answer.
Please do.
I'm saying okay. The short answer is that yes, this will be possible, both in the solutions that Louis is gonna discuss very soon, and certainly as you may know, Starkware has announced that we're doing basically a decentralized network, L2, where anyone can run a node, anyone can run a prover, anyone can put any smart contract on it, and in particular, you'll be able to code whatever things you want at much greater scale. So in particular, yes, you can do that. I just want to remind you, you can use the ask a question. By the way, I see a lot of people are joining in. I don't know where we hit. I just hope that I don't know that the servers or anything don't crash from this. I don't know if it was a joke before or something, but I hope Crowdcast is going to be able to deal with this. Anyways, okay, Louis, please go on.
Yeah,
and I think we'll continue with the split screen, right?
Okay, yes, I can do that.
Okay.
Okay, great. So I can do that. So yeah, I'm going to go back to get my nice presenter view, and I click on the wrong button. So that's okay. Let's continue. Okay, great. So now I'm going to dive into what I was saying was something I'm the most excited about, which is I'm sorry, I would answer that afterwards. Which is the most excited about, which is an idea that I don't think was shared in publicly previously, which is the ability to have cross L1, L2's IMM. And the way to do so is actually quite elegant. So the reason why we don't IMM are a bit harder than borrowing and lending is because they are majorly time-sensitive operation. Also, in the sense that the price can, we are in crypto and the price can get 40, Wi-Fi got 40% today. So if you want to buy now. And but not everyone can pay the $40 and the Uniswap cost right now. So the reason why, if you want, the IMM doesn't scale is because obviously every train goes on chain. So kind of the way we imagine like a potential cross L2, L1 and L2 IMM is by outsourcing leaving the liquidity on the smart contract, but that are outsourcing the state of the IMM to an external operator. Basically, this external operator is here to manage the trade that happened on the various L2s with the various traders, but only settle it at the end of a time period. So let me show you a bit how it works. So just remind ourselves how what is an IMM. An IMM, first of all, for those who are familiar, is the following. An IMM is a smart contract that has three functionality. It has a trading function, a liquidity pool that user can join and leave, and a pricing formula. So a trader can do any of the things that are expecting to him, like deposit, withdraw, and trade. And the IMM can define any pricing formula you wish, as long as it's hard-coded or dynamically defined. It doesn't really matter. So most classic formula are obviously the Uniswap, SushiSwap formula, constant product. You have more advanced one like the generalization by balancer, the customized one like curve. You even have like very cool and fancy one like the Uniswap one. So this is what an IMM is about. An IMM is about enabling users to trade on a market maker, meaning someone that will give me, would always trade against me. And this IMM will protect, this contract will protect the people providing the liquidity by enforcing some hard logic on what the price should be. So now let's look at how we could make it across L2. So in this setting, I have three different L2s, one L1 user, one cross-layer IMM, which is simple smart contract on L1 with a few characteristics, and this operator. Right now, I'm assuming this operator is centralized. Obviously, it can be decentralized. It can create consensus around it.
Louis, could you explain here where is what is on-chain and what is going off-chain?
Yeah, of course. Anything that is on the red area are on-chain. Everything on the outside is off-chain. That's why, for instance, the L2s obviously are off-chain, but the operator himself is off-chain. The user is on-chain in the sense that he wants to do L1 operation, and the smart contract is on-chain in the sense that its logic is enforced in the smart contract. Before I'm diving into how it works, I would just ask, there is a bunch of questions. So I would answer that. So what do you think about, okay, so what do you think about L2-DeFi composability? I will answer this. I think it's a question that is very interesting, but I would rather answer it with Andre's help after the end of print of the different thoughts.
Leave this question.
Yeah.
To the next.
For that developer, do you pay for gas and boarding?
Someone has to pay for it.
I'm going to answer this one. As a dApp developer, do I need to pay for the gas to onboard user on L1 to L2? The user has to pay. It's right now, there is two questions here to answer. The first one is, if you exist on L1, anything you're going to do to join the L2 is an L1 operation. There is no magic around this. But if you are onboarded directly on L2, let's say like a rump network directly giving me swapping a SEPA transfer to ETH directly on the L2, then no, you will have to pay for deposit. Will I be able to run DEX and lending platform protocol at current volume level solely on mine transaction? In other words, will Keeper and meta transaction be capable of allowing DeFi to run gas free? I'm not sure I understand, so I will keep it for later, and maybe Andre will be able to help on this one. Rollup security guarantee is people can exit back to L1. But in the rollup centric world, gas will skyrocket. Being able to exit back to L1 is not good enough for people because L1 transaction is exactly what they can't afford anymore. Can Starkware solve this? So this is a very good question and a very relevant one. What we need when it comes to scalability and when it comes to L1, what we want is something where we want to protect the user not to be stolen. That's the first thing we want to protect. And you're fully right. Will user be able to transact on L1 is not an obvious statement. But if anyone can pick up the L2, then you don't have this problem of exiting anymore. And that is kind of the question we want to answer. I would just drive back to...
I just want to answer that. As a user, that goes to L2, you basically have the option. If you feel secure enough in L2, you can stay in L2 and transact there for as long as you want, and you will see very low gas costs, if any. If you feel for any reason that you want to go to L1, because you want safety or you want to move to some other L2 or anything, yes, then you will have to pay it. But hopefully, over time, you will transact more on the L2, or it will be an option. You'll see what the gas prices are. Maybe you wait for some better time and then you exit at that point. So it's really an option up to the users, and of course both things will have a price, and you have to choose.
Exactly. Okay, great. So I'm going to continue. I'm running a bit late because of the question, but so let's continue. So as I said, 6 entity here, the operator and sorry, I need to get back the the operator, the manage trade, and the smart contract on L1 and the user. Okay, so now what happens is whenever a user wants to trade, it doesn't reach out to the smart contract to get a quote. What he's doing is reaching out to the operator. The operator will provide him a quote, and then the user can say, "Oh, I just want I'm accepting it with a slippage." So now what the user is doing, there is not only the Alice here and the various traders, there is like a bunch of them. And what you can do is you can notice that on the L1, the first L1, the trade themselves are canceling each other. On the second L2, the trade are complementing each other, meaning they go. Oh, sorry. Apparently, it's not big enough. It's not full screen.
No, I think this is a good. It's a good size.
He asked to be bigger.
Okay, yeah, no problem.
Okay, great.
No, you're now focusing on yourself.
Sorry. Yeah, I'm very not good with Chromecast. Sorry for that. Okay, great. So let me get back to this. So yeah, so as you can see, like on the first L1, on the first L2, the user is canceling. The user are trading against each other and canceling each other. On the second L2, the user are just making a trade that goes into the same direction. So they are going to be appearing like a single big trade. And on the third one, a trader is basically matched against one or the other, but the net is provided. So let's continue here. As you can see, what happened on the operator managed to get a 0 net difference on the first L2, but on the second L2, now there is a directional trade. A directional trade that going to ask for, like, basically we output 10,000 USDT, and this user now are expecting to receive 10 ETH. On the other hand, here we have a guy a user requesting 1 ETH and depositing 1 ETH and requesting 1,600. And on the L1, if the user wanted to trade from the L1, he would basically lock his token on the contract with a quote signed by the operator. And now we have the rebalancing phase. And remember that the IMM is all about protecting the LPs. It's always about protecting the LPs. So the LPs are guaranteed execution. And because they're guaranteed execution, they can check that every trade they're receiving match to where they should be on the curve, that they're exactly where the price should be, plus the fees. So now every user gets back what they're needed, and the IMM gets what it needs. So now let's dive a bit why it works. Why does this work with L2s? It works because in the ZKP base solution, scalability, you get instant finality. And when you get instant finality, money can flow in and out instantly. And the second consequence of this is that because it can move in and out, it can do actually crazy things. It can move in, out, do something, back in, within the same operation. So now let me show you a bit of what's possible. And this is what kind of excites me the most about with ZKP-based rollup, is the power of atomicity. In a ZKP-based rollup, you can do L2 to L1 to L2, optimistic execution, and callbacks, which means the following. It means that a user could say, oh, I want to swap USDT for YUSDT, but there is no YUSDT yet in the system. But the network could aggregate the demand, execute the trade as if there was YUSDT, but the YUSDT will only arrive after that, at the moment of the proof of the state being updated. Why? Because I can withdraw the funds. I could flash loan the funds to the Y vault, deposit the YUSDT, swap them, make the transition the proof valid, and reimburse the loan in a single transaction. So optimistic execution, because I'm doing things on the L2, assuming it will be right by the time, it will be true by the time I'm executing it, and callback because I'm calling back the system to reimburse, like to flash through and to reimburse themselves. And this has crazy features. First of all, it provides extreme L1 efficiency, meaning I have the minimum amount of operation to do on L1. The second thing is it provided extremely good UX, because I just mean that the users say, I want USDT. What USDT? Give it to me. Swap it. And although there's no YUSDT, I can do it. And the only major problem with this, which is manageable, is it can if this event is not executed, doesn't happen, then it will provoke a batch failure. The L2 will not be able to settle. So this works very well when either the system is not the protocol is not time sensitive, or then you actually trust the contract you're going to call very extensively. So now we also another approach, which is the asynchronicity approach, where here I'm creating, what I'm doing is that if a bunch of users wants to do the same thing, I'm going to pool them together. I'm going to pool them together and simply aggregate the pool, the money, create shares, create distribution, aggregate the money on L1, and then execute what I need to do. And the main advantage of this is that it cannot create the batch failure, because if the event doesn't occur, then the user just get their money back in the next batch, actually in the same batch. But so it provides a lot of flexibility and enables, synchronicity, to provide resynchronize various events of various L2 through the synchronicity of the L1. The problem is, the cons, obviously, is that it's a much more complex system. UX-wise, it could require up to two signatures, and also it creates some arbitrary abstraction that are, somewhat complex. But this more or less works with any system. And the design I show for the IMM is fundamentally based on this ability to do things asynchronously. And this capital efficiency, this ability to withdraw, to get my money back, like Thatcher would say, give my money back. So when can you use this? So first of all, a bit about Starkware here. Starkware has two product lines, and two product lines that exist today. The first one is one that has been live for 9 months, called StarkX. StarkX is a non-custodial environment for trading and swapping. And in StarkX, so StarkX has been live with diversifying for 9 months. Will be live with Gods on Chain, Immutable Gods on Chain, and DYDX this month, if I get the date correctly, and more to announce very soon. And while we cannot do this exactly like in the current version, we will be enabling the synchronicity approach in V3 through two new features, which are respectively the ability for a contract, or for actually any L1 account, to create an order, a limit order, a swap order, directly from L1, which would be valid on the L2. The second thing is, I will be able to hold assets for the user directly on an account on the L1 that is valid on the L2. So basically, you could have a contract that means LP to shares, deposit them, create a limit order at a specific price, and we're swapping them. This is what we're describing in DeFi pooling. And now we have the two things that we are not completely, I didn't describe previously, which are the efficient commitment. So the efficient commitment looks a lot like the HOP exchange from the Ethereum presented. It's something that we know how to build. We just didn't have the interest yet, or didn't present it publicly yet. And callbacks is the same thing. We know how to build it. We actually tried, very easy for us to build it, but it's kind of we're still looking for people who wants to build that. But now let me present Starknet. And Starknet is what you think when you think about a general purpose L2 solution, ZK solution. It's a full-blown Turing complete L2 solution. And Starknet will come in 3 phases: Planet, Constellation, and Universe. Planet is the ability for you guys to take Cairo, which is our Turing complete language NVM that is available for you to play around. Eli sent the link. You will be able to write your own Cairo code, output your own information, write your own smart contract, and run it by yourself without talking to us. And that is something you can do. You will be able to do all of what I described by yourself without talking to me. All of them very nice. And next week, sorry, I think very, very soon on this, we will have a tutorial, for instance, how to write an IMM on Cairo. And Constellation is roughly the same thing. The only difference is that it enables you to have multiple applications running through the same centralized operation. And Universe is what people are the most excited about. Universe is basically the full-blown version. Think like the perfect L2 you dream for, meaning decentralized provers, proving things for you, smart contract that you don't have to run, and written in a language that enables you to do whatever you want. So on this one, we will have like L1 to L2 execution and L1 account. The efficient commitment is not something you would have even to talk to us about. You can write it yourself directly in Cairo. The only thing that is a bit more complex but feasible is enabling any smart contract to do arbitrary callbacks from the L2 to L1 without having any sort of authorization from the provers. So this is feasible. This is what we were looking into, but a lot of that is TBD because obviously arbitrary computation could be dangerous, could bring a lot of complexity, and we need to solve that first. But anyway, I just want to thank you for listening to me. This is the end, and because I'm French and apparently DeFi the future of France. So merci beaucoup.
So now, before we hand it over to Andre, who's let's just answer. You said that a few of the questions are going to be answered by him, but okay, this will leave Andre is going to answer this one, I guess. Let's see which one. This again, we said.
Yeah.
Estimate.
Well, actually, before we get to that, I want to add a little bit of context as well.
Go ahead. So we're moving to you, please.
Because a nice thing about sort of what you can do on layer 2 is you can reduce any layer 1 action as a trade, basically. So what I mean by that is there's obviously the basic AMM trade, which let's say you want to trade ETH to DAI, you're going to transfer ETH to the smart contract and you're going to get DAI back. Now that's a traditional AMM exchange. But like if you think about something like a yield aggregator, let's take Yearn for example, it works the same. If you want to deposit ETH into the YE vault, you give ETH, it gives you a price that ETH is worth, and it gives you YETH, and that's also just an exchange. If you look at a lender, let's look at Aave, you want to deposit DAI, you are exchanging DAI for a DAI at a specific price and exchange. If you want to borrow against that a DAI, and let's say I want to borrow ETH, I'm exchanging my a DAI for that ETH. So almost every action, whether it's borrowing, exchanging, yield aggregation, you name it, can be sort of condensed to trading asset A for asset B. So like I'm trying to sort of dumb down what was being explained during the presentation now, in that once you have your initial asset on the L2, so that requires locking it into a smart contract on the L1 side, and then it becomes available for you to use. You can sort of think of it like also being backed by an asset. It basically becomes a stable coin on the other layer. That's 1-to-1 of the value of the underlying. But like once you have it on that L2, you can do any of those exchanges because the L2 is aware of the exchange rates on that L1, especially with that very cool L2 to L1 callback to L1 method. You can lock in those quote values. So like if you want to be on an L2, Yearn doesn't have to exist there. Aave doesn't have to exist there. Compound doesn't have to exist there. All that you need to be able to do is trade DAI for C DAI or DAI for A DAI and A DAI to ETH if you want to borrow it. So like just by virtue of the L2 knowing these, let's call them quoted price values, which are fixed according to the rules, it can facilitate any of those actions without any of those systems actually needing to exist. And that starts making it incredibly powerful. Because a big problem now with sidechains, L2s, you name it, is the migration problem. It's like all of these people need to migrate. Yearn can't move unless, Aave, Compound, Uniswap, SushiSwap, everyone else moves, because we need to build on top of them. Aave can't move, until DAI, ETH, USDC, Link, etc. token moves, because they need those assets. So by being able to do something like this, get the quote price on L1 and then just doing the exchange on L2, you unlock all of the functionality of L1 while being able to do it in an L2 gas minimum instant finality environment. And like, technicals aside, that is incredibly powerful.
Mm-hmm. So, Andre, do you want to answer some of the questions and then basically, continue and speak what your thoughts on this?
Yeah, let's go for it. If you don't mind reading them out for me, then
yes, definitely. So, hello all. What do you think about cross L2 DeFi composability?
So we've been seeing. I'm not recalling the project's name, but Arbitrium, I think it is. That's doing the cross L2 swaps. So it allows you to transfer between like Optimism and ZK rollups or things like that.
It's our Ethereum. I think it's Up Exchange you're talking about. Actually, I quote them because the commitment I was talking about is inspired by their design.
Oh, okay, that's very, very cool. So I actually don't know on a technological level how they do that. I don't know if you have any more insight on that, as you can maybe give us a quick high level.
Sure. Actually, that someone quoted also there is Connex at the state channel between the two, between layer twos. I mean, actually,
okay.
That's Connex, but what the Ethereum guy did with OPEX is what they're doing is they are minimizing by using an efficient cryptographic commitment. They are bundling, compressing all the assets that are moved from one L2 to another L2, and moving it to using those bridges. Like basically, you're going out and you are committing, and then you can decommit it on the other side.
Okay. Next question is, I think this is a question for us. Estimate on when EVM compatibility will be ready. So I'll answer this one. So not necessarily soon, but I mean, what you really, really want is to have the functionality and the expressibility of EVM. Because let's put it this way, because of the severe gas limits and the severe limitations on computation on L1, the actual logic of many of the smart contracts that you would like to move to L2, that logic is very, very lean and simple, okay? Because of these limitations. So realistically, your best chance is getting, if you want to build, let's say, an AMM on our L2, which we highly recommend, your best chance, and I'm going to repeat something that I said earlier, your best chance is basically writing it from scratch. And the way to write it from scratch here is I just, it says that I already sent this message, but I do want to send it again. So I don't know why it's not resending my message.
I'm going to do it. I'm going to do it myself.
I'm just
scrambling, yeah.
So basically, I'm trying to post here the links to where you can go and learn how to program your AMM. And this is going to be much, much faster than waiting for EVM compatibility. And I think it's also going to become much better. As we said earlier, within a week or so, there will be a tutorial there with an AMM, a rudimentary AMM that you can basically take and sort of complete it into an AMM and get your own AMM on L2 with very low gas cost, if you know how to, program or to test it in prod, as some people here know. Okay, next question, I think this is for you. Will we be able to run DEXs and lending protocols at current volume levels by integrating L2? Additionally, will keepers be able, I guess it's,
keepers.
Keep 3 ERs, be able to introduce gasless swaps and TXs with L1 to L2 meta transactions? Anli, do you want to answer this, or
Yeah, no, 100%. So just for context, there's basically 2 subset products that we have sort of developed. So the one is Meta Wallet, which basically uses, for those that are familiar with like the GSN network, where you can relay a transaction based on a different asset than ETH. So you'll have a relayer that's willing to pay your gas, and in exchange for that, they'll take some DAI or whatever it is that you have available in the transaction. So it sort of subsidizes the costs. So Meta Wallet is sort of like a Gnosis or DS proxy wallet, if you want to think about that. That's automatically integrated into this relayer network. So it doesn't require sort of signing extra transactions. You use it as a base wallet. And then it is, the relayer network itself is Keeper Network. Keeper Network is a just decentralized sort of Keeper job board, where people post things to execute at specific times or at specific events or with specific triggers. And then when those triggers are met, execution happens. And the nice thing about it working with Meta Wallet is that Meta Wallet is designed completely with a permit scheme. So what that means is normally with a transaction, when you execute that transaction, you execute it on chain. With a permit scheme, you can sign it off chain and then use that signature that was signed off chain to execute an action. And because we're combining Meta Wallet and Keeper, you can actually collect a batch of these transactions, then batch them all into a single execution when a time trigger or whatever is met. So it's kind of like a very overly simplified on-chain version of batch transactions, and to be able to like offset gas costs and that kind of stuff. So one of the things we do want to do with that, and we also want projects to incentivize doing that, by actually like paying in their token to subsidize the gas cost, is to use that infrastructure to allow for near gas-free commits into layer 2s. Because now if you use that infrastructure and you want to transfer your tokens or your ETH or whatever into a layer 2, then that network subsidizes all of those events for you. And because it's batched, it's cheaper because it's combined with a bunch of different signature transactions, etc. Sorry, that was the second half of the question. Can you just read for me again the first half of the question?
Let me get the question. We closed it, so let me get it.
Sorry about that.
Okay. Will we be able to run DEX and lending protocol at current volume level by integrating L2? I'm not sure.
Well, I mean, like that's it. You'll be able to do more. So L1 volumes and transactions and everything else is basically limited by 2 things. It's how often do blocks occur, and it is how much actions can you fit into a given block given the gas limit. As soon as you start moving these things onto L2, you don't have those limitations. You move away from block limitations. You have things like instant finality. It's how many proofs can you generate in a given time frame. So trading can actually happen exponentially faster. Lending can happen at a significantly greater scale, although it is obviously limited in terms of the amount of capital you have available to create the borrow volume. But yeah, like L2s don't limit what you can do. In fact, they provide access to increase it quite a few fold.
Awesome. There is, I guess, a question for me, I guess. How much would this L1, L2, L2, L1, L2 operation cost in best case? So, I mean, the point is, are we talking about marginal cost, or are we talking about like including the proof? The TLDR, if we just talk about marginal cost, it would just be a single, like the equivalent of depositing and into Wi-Fi the Y vault and staking, like redepositing the receiving asset to the deposit area of the user. So the TLDR here would be like the cost of you depositing into Wi-Fi. Okay, so how trustless is Starkware L2 solution? I'm going to enter this one also. So it depends. What do you mean by trustless? Starkware solution, StarkX, StarkNet are trustless in the sense they're not custodian. Now they're not censorship resistant. And if you want to get censorship resistant, we will have to wait until StarkNet and the third phase of StarkNet. I hope it answers the question. There is one question for you, which is not related to the topic, but I'm sure I will read it anyway. Other chains have different iteration of impermanent loss protection for liquidity provider. Is this something that can be done on ETH? And if so, do you know if anyone is looking into this at this time?
Definitely lots of people looking into it. Everything from like trying to apply something like straddle options to sort of using lending of the other assets. So you sort of have a short position against it into your AMM for if, you know, it offsets. The biggest problem there is actually more to do with like how these AMM curves work. If you look at something like the constant function, you know, impermanent loss is basically a exponential change on the assets versus what you would have experienced if you just held the assets. So like when you do a borrow position, you also suffer that exponential loss, and that kind of hurts you more. The problem with options again is, you know, they're not perpetual and they need a lot of micromanagement, and just options pricing currently on chain kind of make them prohibitively expensive. So you need to sort of change that design into a utilization based money market where you're sort of borrowing the option instead of paying it for the whole time and then trying to use fees from the AMM to offset it. But yeah, like the simple answer is lots and lots of research happening in that field, but it's progressing slow because like it is a very difficult problem to solve.
Thank you very much. So now maybe I know if we're going to be over time, but I would love to hear what you think about like more. I guess me asking you question is, how do you see the future of DeFi? Like what's your the future of DeFi when it comes to L2s? How do you imagine in addressing it?
Well, so it's to me, it's not really just about rollups. You know, like I think rollups are definitely a very strong solution, but like in a lot of cases, if you consider something like wrapped BTC, right? Wrapped BTC is a perfect example, even though it's centralized. So I won't go too much into that argument, but we've seen the need of chains also needing to cross communicate with each other. And I think we're kind of getting closer and closer to sort of having a chain cross communication protocol. So a way I always like to explain it is, you know, early days, pre-internet era, we had LANs. You had local area networks where people connected to each other, and that was a protocol that all the PCs knew how to talk to with each other, and that's how you communicated. But that didn't go outside of that local network. Yeah. And then you started getting WANs, and you started having a little bit more of a wider area that you could communicate maybe in a like whole neighborhood or a city or something like that. But finally we got internet infrastructure, and even that was slow. You started with dial-up, moved on to ISDN, ADSL, and sort of moved up that way. But like right now we're sort of at that LAN stage still. I think L2s move us to kind of the WAN stage, if I can call it that. But
it's charging. But L2 is opt-in charging. That was a very good definition given to me by Georgios.
I like that one. I agree with that sentiment, opt-in sharding. Because you deposit, so you opt into the specific shard you want to communicate on. But like my final sort of vision / roadmap is some kind of real decentralized cross-chain communication protocol, more so than just like wrapping assets, but like ideally actually at a level where it's almost like TCP, and all of these chains are talking that same language. I think we're very, very far away from that, probably decades, but sort of that's where it needs to get to, because the reason it needs to get there, and I like that opt-in sharding, because it's the same for other chains. You know, if you move your assets to Solana now because you want to use Serum, you know, you're opting into that Solana/Serum shard. But I do think we're going to see, because ETH right now is just obviously super congested. There's just too much happening there, and the analogy there is just like, you know, a city. When the first city sort of starts, it very quickly gets incredibly overpopulated, and as that happens, people start moving out and they start establishing other cities around it. And we're starting to see that with asset sort of outflow from ETH onto other layer 2s or different chain solutions and these kinds of things. And then, you know, they'll establish sort of their own little ecosystems and communities and all of those things. I mean, I think UX is probably the biggest prohibitive at this point, and I think it's going to be a prohibitive for a while. But, you know, eventually that's also going to be solved. And you know, it's going to get to a point where your MetaMask, a website can inform something like MetaMask, what are you connecting to, why are you connecting to it, what should you be connecting to, and like then the user doesn't even have to select which one they're talking to. You know, sort of the dApp can pre-inform their wallet what they are talking to, and once you get to that, you've solved UX, you've solved cross-chain asset transferability, and you know, then you're kind of more at, but I don't even want to limit this to DeFi only. Like DeFi sort of exists as the big product right now because DeFi is financial value, and you know, an Ethereum transaction is expensive, so you're only going to pay for something that expensive if the value you can get is more than what you're paying, and that's sort of why it's a very logical financial instrument area currently. But you know, as we get more cross-chain, as we get more roll-ups, as we fix the UX thing, like it's not going to matter what chain it's on, or what the fees are, and you're going to start seeing a lot more other solutions. You know, you're going to see high privacy social networks, you're going to see communication apps, chat apps, you're going to see, you know, like video calls, encrypted video calls happening. Because like blockchain as an infrastructure and sort of as an encryption layer can be used to, you know, address a lot of the problems. Like an explanation I like to use there is, you know, so sort of blockchain's adoption came from things like, you know, 2008 financial crisis and these kinds of things, where people realized, you know, oh shit, if I don't actually control my funds and I leave it somewhere else, like it's actually a big problem. Like that can mean I can lose everything. So they wanted to move to something where they own it. Now, if we fast forward to like today and we start talking about, you know, censorship and privacy concerns and like everything happening in like big tech in America and that kind of stuff, then, or you know, even something like the Great China Firewall, like all of a sudden you're seeing that same sort of tipping point that happened in our financial space, but you're seeing it in terms of privacy and data ownership and these kinds of things. And when that tipping point happens, you know, the same sort of migration to blockchain is going to happen. So like to me, it's a lot broader scope than just DeFi. And I think we're eventually going to get to a chain agnostic point, you know, like everything's just going to communicate with everything. You might have like a settlement layer, you know, like ETH is a high security settlement layer, BTC is an even higher security settlement layer, and then everything else sort of talks around it, batches what they do, and then settle that on the settlement layer. Yeah, I mean, I think that's definitely sort of my decade worth vision for where this is all going. It's going there a lot slower than I would have liked, but you know, that's the nature of tech. When someone asks you how long is it going to take, you're like, I can probably do that in 5 hours, and then 4 weeks later you're still busy debugging stuff. So yeah, like it's maybe a little bit grandiose, but I think that's where we're moving towards.
Very interesting. I have this interesting question, and I guess it's also interesting. We will answer it too to some extent. Currently on Ethereum, derivative AMM are limited to the limitation of EVM, especially option AMM are not optimal because computation variable like the portfolio delta of the liquidity pool is an unbounded computation. Do you see L2 being able to solve this computer issue? So I will start, if you allow me, before I let you on more of the financial aspect. That's actually a very good question. And we, Cairo enables you to make, arbitrary long, like Monte Carlo simulation, or not arbitrary long, but like to some extent, and prove it succinctly on layer one. So we do imagine people coming with interesting hard computation that they want to prove on layer one. And I guess it's now that I say that, I'm sure Andre, you have a lot to say about it.
No, like I agree. It's just something like EVM or ETH rather. It's bounded in terms of computation. There's only so much you can do in a given gas limit, and then especially if you start looking at the block size limit. So it's the same reason we don't see high frequency trading on chain, because it's just too computationally expensive. But when you start looking at things like proving networks, and you start looking at things like ZK proofs, or even some of these other higher frequency, less decentralized networks, then you start increasing the amount of computation you can do, especially if you start moving it off chain. And that's why, for example, something like limit orders right now doesn't work in a EVM based space, because something like a limit order needs a matching engine in the background, and that is a lot of computational power that has to happen to be able to accurately calculate, what is my order book depth, how do my iceberg orders look, etc., and then calculate that actual price. Now you can't do that on the EVM, but you can do that on a rollup or on a higher computational chain. So there's a lot of sort of restrictions we currently have in terms of what we can do because of, let's call it, computational restrictions, but those get alleviated when we start moving from ETH as a computational layer and instead as a settlement layer.
Next question. Andre suggests a chain agnostic future. What about a bank putting 500 billion in bonds on chain? Will that bank see Ethereum's property rights as fungible with, for example, Solana?
So urine comes in the trade-off, like for something that's faster, you're going to sacrifice something. 9 out of 10 times that's decentralization. And that normally comes with certain security guarantees as well. So this is sort of where the FAT protocol thesis came in. For those that are not familiar with it, it's this basic theory that let's say you have a chain, right? And this chain has whatever 100 validators, and it's a proof of stake system, and they're all staking $1 million. So 100 validators, $1 million each. So that means the security of the system is $100 million. But now you don't need $100 million because let's say it's BFT, so you need 2/3 participation. So let's say you can control $66 million worth. Now, normally that's not worth it because you attack the chain with $66 million, and now what? But now if there was an asset on that chain, let's say Tether existed on that chain and it was worth $1 billion. Now all of a sudden spending 66 million to attack $1 billion starts making financial sense. Maybe Tether is a bad example, but like let's say there's $1 billion worth of Bitcoin, and like I can control the chain and then stop all trades while I like that. So those now Ethereum already kind of disproved that, because like Ethereum assets is already worth more than Ethereum. But at the same time, it's not like a single value thing. So in that bond example, like if a bank decides let's do $5 billion worth of bonds, they're probably not going to do it even on Ethereum today, maybe. But like the security guarantees there, it's still semi-attackable. but you're definitely not going to do it on a chain whose security measure is like, $10 million, because then you're just asking for that to get destroyed. So there's a lot of sort of considerations between what is it I'm trying to do. Like if you're doing a chat app and you want encryption, then by all means go for a fast chain, go for a Solana or a L2 implementation or something like that. But like if you want maximum financial security, because you want to issue millions or billions of something, whether it be bonds or assets or capital backed securities, doesn't matter, then you're going to go for the highest security. But at the same time, when you're doing that kind of financial value, you're not that concerned about things like transactional throughput or speed of settlement. I mean, so let's take 3 chains as an example. Let's say Binance Smart Chain, let's say Ethereum and Bitcoin. Like if you were to move $1 trillion and you want to be 100% like sort of peace of mind on that, which one are you going to move it on? Personally, I'm going to choose Bitcoin because like that's got the most financial value to secure that kind of settlement. Second would be Ethereum. Third would be BSC because like there's validators that can control what's happening there. So it's use case driven. Like any app, you decide what's the best tech stack to facilitate what that thing does. It's the same reason that we don't just have in traditional technology, we don't just have one database. There's Mongo, there's Redis, there's MySQL, there's Postgres. There's so many options because each one has different trade-offs and benefits in terms of what you can accomplish with them. So you choose the correct stack for the thing you want to accomplish. I hope that answers the question. I know it was a little bit long-winded, but like it's important to understand security guarantees versus throughput and usability and these kinds of things.
Obviously. Let's
answer like these 2 more questions,
yes.
And then I think we'll let you, Andre, wrap it up. Okay. Okay, let's read this question. How do you feel about having insurance and coverage in the crypto and DeFi space? With more and more moving parts being added every day, insurance is one of the biggest aspects of finance. Right now, it seems, sorry, I apologize. Right now, it seems DeFi is mostly bank and yield focused, but is the next big thing on-chain insurance? Have seen tweets regarding it.
In my personal opinion, yes. So like I'm heavily focused on insurance at this point because we're going to start seeing more and more things go wrong. Like it's just the nature of bad events. Like if it can go wrong, it will go wrong is a fairly accurate generalized statement. And like we're seeing more and more things sort of premise up. The problem with insurance, right, is something bad has to happen for people to think about insurance. If everything's going well and everything is, just happening as per plan, then people don't think about it. You don't think about funeral insurance unless there was a near-death experience or a death in the family or something like that. You don't think about car insurance unless you saw an accident or you were in an accident or something like that. So like, a year ago, there weren't a lot of incidents, so insurance wasn't important, but we're seeing more and more incidents, which means insurance becomes more and more important. A big problem with insurance right now is 2 parts really. Like part 1 is capital efficiency. Why are you going to put $1,000 of USDC into backing an insurance claim that could be at risk, at 8% APY, which is still a fantastic number, but you could be earning, 105% on Curve USD input. So like, which one does the capital efficient person choose? Or rather yield efficient person choose. So there's definitely a problem that needs to be solved in terms of sort of payoff versus risk. And then the other one, insurance right now, due to the nature of blockchain, because we don't really have stuff like, debit orders that can trickle, is it's all designed to be upfront. And like upfront, if you had to go to your insurer now and you wanted life insurance for the rest of your life, and you are estimating you're going to live up to 90, and then they tell you, okay, well, this is the lump sum, please pay up front. Like most of us aren't going to be able to afford that in a single sum, but on blockchain we do that. So it has to move to sort of money market based utilization ratios so that you can actually just sort of have a trickle against your values. So there's definitely still, let's call them UX problems to solve. These aren't really technical problems as much as they are just aligning it accurately. But once we've solved those, I definitely think making it easily accessible and efficiently usable is the next big wave there. But like right now, it's super clunky. Like I don't blame people for not using insurance currently, but we're on chain at least. We're going to see a big boom in that.
Okay, so that is the last question. I'm going to take it because can you build a rollup on top of a rollup? So that's actually an interesting question. It depends on the rollup. So on an optimistic rollup, there is not really much sense to it, because in the sense that an optimistic rollup is just about a sequencer gathering the data together and pushing it on chain. So I mean, maybe I'm not aware of any interesting consequence of doing a rollup on top of a rollup. But in a ZK rollup, there is actually interesting consequence to it. First of all, using recursion, you can enable you can actually make it cheaper for the users of your second rollup to use the first rollup. And the second thing is, and so something that no one actually talked about, is that any rollup, ZK rollup, assumes on-chain data. And on-chain data has a non-compressible cost of, to put it simple, 1,000 gas. So we will see at some point a case where, like, even on a ZK rollup or an optimistic rollup, I mean, this is true for ZK rollup and even more true for optimistic rollup. So I do think that in some near future, we actually will have what in the context of a rollup, we call volition, where you can, in a ZK rollup, you can actually choose to have your data on-chain or your data off-chain. So in that context, you could have like a volition system on top of like running on top of another rollup. And in that context, you would hide your data from like basically make it cheaper for users to interact. I might have one last question to Andre just before we summarize, before he wraps it up. I would love to hear his thoughts about what was presented, like more about like on terms of like a direction, and if he's from his perspective, you see other direction when it comes to L2. We'd love to hear a bit about this.
I don't think it's sort of a winner takes all scenario. Just like, it wasn't with blockchains. Like everyone always acted like it's, Highlander, there can only be one. So to me, there's a lot of different solutions that solve specific vertices, and we'll be seeing each solution gain its sort of own dApps and its own builders on top of it. I think now we're sort of still in that ideation phase where it's not yet ready to be used in that level, and sort of the people playing with it now are the pioneers, the trendsetters, the groundbreakers, whatever you want to call it. To me, and maybe this sort of ties into my closing thoughts as well. To me, it's a lot about this space moves incredibly fast, like in terms of news, in terms of new ideas, in terms of just market pace, really. So people always have this it should already be solved almost expectation, like the gas fees are now a problem. Why aren't we already on L2 is almost sort of the mentality, versus, tech, and especially good tech, takes time. It's a very long, arduous process, with normally, lots of reinventions and lots of things we have to rethink and replan and redo and often rewrite. And like, to me, a lot of the stuff we're talking about is a 5-year, 10-year, maybe optimistically 3-year timeline. But the expectation is it needs to be ready next week. And like I worry a little bit about more about how we sort of align those expectations. But I mean, expectation management has always been a problem in tech. It's not a new problem we're having. I think it's just expedited. But that being said, the future in terms of L2 solutions definitely looks bright. Like from all the teams I'm involved in, it's a daily conversation about where's everyone going and how far is their research and who's being dedicated to those teams to sort of get into these areas. So I don't think it's, like a year ago, the question was if it's going to happen. And I think now it's a question of when it's going to happen. So that's a very positive step, but I think there's still going to be a lot of hardship before we get there. But sort of the comfort I want to give, users and builders is all of the people potentially listening is, where we are getting there. Like it's not going to happen as fast as most think, but it is going to happen. So like people had frustrations on the early days of internet. For anyone in this chat that remembers the frustration of waiting for a dial-up website to load versus now you click on the thing and if it isn't there in like 300 milliseconds, you almost rage quit. And like that's a massive technological difference that happened over decades of improvements. And we're doing the same. And the fact that we're on this call and we're talking about it means we are, and I actually hate using this phrase because it pisses me off when I see it online, but like we are so ridiculously early still that there's so much more to come.
Terrific. Okay. Okay. So I mean, we went overtime, but I think there's a lot of still interest. So I just want to sort of wrap up and say the reason we at Starkware are interested in basically doing this particular episode and drawing attention to L2 is of course that soon anyone can sort of write your own AMM or any other DeFi application that you want on on this framework that will become and evolve to be Starknet, that anyone can also run their own node, the L2 that will have the ability to run any arbitrary logic with much lower gas cost. And if you're asking yourself, how do I if I want to be number 2 on whatever list that was next year on Telegram next year, and replace Andre by being the DeFi architect of L2. So you need to press this button down here, start learning Cairo so that you can build the quickest and fastest scalable Stark-based L2 that will give you the lower gas fees and all the beautiful functionality that you need. Okay, I see, Andre, you have here a marriage proposal and other things, but I think our time is up. So thank you very much, Louis. Thank you, Andre, and see you all next time.
Thank you all. Appreciate it.
Bye.